Welcome back, everyone. So far in this chapter about area and perimeter, we've learned about 6 different shapes and how to find the areas and perimeters of those shapes. Now we are going to talk about finding the area of regular polygons. So remember, just as a refresher, regular polygons are polygons where all the sides are congruent and all the angles are congruent. Regular polygons can be inscribed in a circle. When this is done, you can see that the center of the polygon is the same as the center of the circle. And there's some vocab that you need to learn. The first is called an apothem. An apothem always travels from the center to the midpoint of one of the sides of the polygon. Segment PF is an example of an apothem. The apothem always creates a right angle to the side of the polygon. Next is a radius. This is a radius of the circle. It goes from the center of the circle to a vertex of the polygon. AP is a radius of the polygon. For example, angle APB is a central angle. If we follow those letters in order, APB creates this angle. In order to find the measure of that central angle, you would want to do 360 degrees divided by n for the number of sides in the polygon. Let's practice this vocabulary with another example. So we need to go through and identify each of these vocab words and then find the measure of the central angle. So I already wrote them in here, but let me go over them with you. So the center would be point K, since it's the center of the circle. A radius, you could either use KG or KH, since they both go from the center to a vertex. Next, for an apothem, you need to take from the center to the midpoint of one of the sides. KL is an example of an apothem. Notice it also creates a right angle with the side of the square. The central angle, for example, could use GKH. The measure of the central angle, you could do 360 divided by 4, since there's 4 sides in a quadrilateral. So that's how I knew the measure of angle GKH is a 90-degree right angle. Go ahead and try the practice problem below on your own. Here are the correct answers. Alright, let's talk about finding the area of these polygons. So first we're going to look at the polygons as a division of triangles. So you can see here I've numbered these. It's an octagon, so it can be split up into 8 congruent triangles. I know that the equation for the area of a triangle is 1/2 base times height. So if I want to find the area of the octagon, I know that there's 8 of these triangles, so I'll do 8 times 1/2 base times height. Now, in order to find the area of the triangle, I need the base and the height. In this example, I redrew the triangle here. I see that the side of the triangle is 15, the side of the window, so that means the base of the triangle is 15, and the height of the triangle is 18.1. Now, I can plug that in, so I use substitution. The base is 15, the height is 18.1. Remember, those are perpendicular to each other, so I can use them for base and height. And then to solve it, I would just plug this into my calculator, and you should get 1,086. So your answer with the units, you would use 1,086 inches squared, since we're talking about area. I want you to try the next example on your own. Here's the answer for the area of the lid for the hot tub. Now let's talk about another equation that might come in handy. Now sometimes that previous method of finding the area of one triangle and multiplying by how many triangles there are is effective. At other times, you might want to use this formula for area of a regular polygon. It's 1/2 AP, where A stands for the apothem, P stands for the perimeter. This is just a variation on what we were already doing. Let me show you an example of using this formula 1/2 A times P. So it says find the area of the regular hexagon shown, round to the nearest tenth. So the first step that I would do is find the measure of the central angle. I know that the central angle measure is always 360 over n. In this case, it will be 360 over 6, since there are 6 sides in a hexagon. So I know that this central angle measure, ABC, measures 60 degrees. That means when I draw this other little right triangle off to the side, angle DBC would be 30 degrees, because half of 60 gives me 30. Now it's helpful to redraw the right triangle off to the side so that I can find the length of the apothem. I know that BD is the apothem, so I know that I want to find the length of BD. This triangle is a special 30, 60, 90 triangle. Now, I need to know one of the sides in order to find the others. So take a look at our hexagon here. Notice side AC is 3 meters long. That means that side DC would be 1.5 meters long, because half of 3 is 1.5. Label the sides for the special triangle. Across from the 30 is S, across from the 60 is S square root 3. Now, since S is equal to 1.5, that means that BD would be equal to 1.5 square root 3. Now I can go ahead and substitute in for my formula. I know that the apothem is 1.5 square root 3, and the perimeter, since every side is 3 meters long, this is a regular polygon, so remember all sides are equal, I can take 6 times 3, since there's 6 sides and they're each 3 meters long. Now to solve, I can plug this into my calculator. If you'd like, you can plug in just the 1/2 times 1.5 times 6 times 3 first to give you 13.5. That still needs to multiply by radical 3, so this would be the exact answer, would be 13.5 square root 3. And if you wanted the approximate answer, you could go ahead and type in times square root 3 on your calculator. It should give you 23.38. To round to the nearest tenth, since 8 is greater than 5, we would round up to 23.4. And remember, you must include units with your answer. Since it's area, it will be units squared. Let's go ahead and try another one. This one is a regular pentagon. Remember, the first step should find the measure of the central angle. In this case, our central angle is angle RPQ. Take 360 over n. In this case, do 360 over 5. 360 divided by 5 is 72 degrees. So I know measure of angle RPQ is 72. Now, to find the measure of angle RPS, it would be half of 72. So I know that this angle RPS is 36 degrees. I'm going to draw it off to the side to make it easier. I know that the measure of angle segment PR is 10 inches, so I drew that in my diagram also. I still need to find PS, so I know the length of the apothem, and I still need to find RS so that I can find how long the total side is and find the perimeter. Now, this one, unfortunately, is not a special triangle, so I'll have to use SOHCAHTOA. Go ahead and label your sides based on the 36-degree angle. I have the hypotenuse is 10, the adjacent would be PS, and the opposite would be RS. Now let's go ahead and find PS first. In order to find PS, I'm looking at the adjacent and I have the hypotenuse. So I'm going to use cosine. So I would do cosine of 36 degrees equals the adjacent, so PS, over the hypotenuse, which is 10. To get PS by itself, I need to multiply both sides by 10, and that gives me PS. Next, I said I also need to find SR. In order to find SR, I'm looking at the opposite and the hypotenuse. So opposite hypotenuse, I know I should use sine. So I'll do sine of 36 degrees equals the opposite, so RS over the hypotenuse, which I know is 10. Again, same as before, multiply both sides by 10 to get RS alone. Now I know that PS is the apothem, so I have this is the length of the apothem. You can just leave it like this and plug it all into your calculator at once. I still need to find the perimeter in order to use my equation. I know that RS is 10 sine of 36 degrees. So from here to here, I know this is 10 sine of 36 degrees. Remember, RS is half of RQ. So if I took RS and multiplied by 2, I would have 2 times 10 sine of 36 degrees. Or in other words, I get 20 sine of 36 degrees is the length of every side. Now that will help me find the perimeter. Let's go plug into our equation now. I said the apothem was 10 cosine of 36 degrees, so I'll plug that in for A. For the perimeter, there are 5 sides, so I need to take 5 times. Remember, I said each side is equal to 20 sine of 36 degrees. Once you substitute in all your values, you can plug this into your calculator. This would be basically the exact answer. You would be able to multiply the 1/2, the 10, the 5, and the 20 together, but this one is more one that you would probably just find an approximate answer. So in this case, you should get 237.764 on your calculator. When rounded to the nearest tenth, since 6 is greater than 5, you would round up to 237.8. And the units for this are inches. Since it's area, it will be square inches. On the next page, I have 3 practice problems for you. These are all regular polygons, but I want you to use the best way that makes sense to you. So do your best and try to be efficient with the choices that you make for which equation to use. And you could go ahead and try those on your own now. Just do your best, see what you can do. Alright, the first one was a triangle. In this case, I decided to just use the area of the triangle because I knew since it's a regular triangle, it must be equilateral. So I knew every angle was going to be 60 degrees. So I just broke it in half to make a 30, 60, 90 in order to find the height. I used 4 as the base and 2 square root 3 as the height, and plugged it into my area formula. You might have done it differently, but you should still have the same answer, 6.9 feet squared. Next, since this is a quadrilateral and it's regular, I know it's a square. So again, instead of using 1/2 AP, I decided to use the area of a parallelogram. Because with a square, it makes it a lot easier since both sides are the same. All 4 sides are the same. And they have all right angles. So I first found that the central angle measure was 90, so I redrew my triangle, and I knew it was a 45, 45, 90 since the diagonals bisect these opposite angles. So I knew that that was going to be a 45, 45, 90. I labeled the sides S and S square root 2. So since S was 7, each side must be 7 square root 2. So I plugged that into my formula, 7 square root 2 times 7 square root 2 to get 98. No matter how you do the problem, you should get 98 centimeters squared. Finally, for 3C, with this one, it was an octagon. So I actually had to go through and do the formula 1/2 AP this time. And it turns out that my triangle that I highlighted, I redrew it down here, and unfortunately it wasn't a special triangle. However, I could find the base of the triangle by using SOHCAHTOA. I needed to use tangent since I had the adjacent and I wanted to find the opposite side. So I used tangent to find the length of YZ, that's what I decided to call it, and that helped me find the length of every side in order to plug it in for the perimeter. Once you plug it into your calculator, you should get 212.1 inches squared. Finally, for today, I know these are kind of difficult, but we'll practice them a lot more in class. I want you to try to look at these 2 problems. So we have 2 different people solving for the area of the regular hexagon. I want you to go through and see if their work makes sense, if either of them are correct, or maybe neither of them are correct. Let me know how you would solve this. If they're both incorrect, what's the correct answer? Explain your reasoning in 2 to 3 complete sentences. Thank you.